Hello, my name is Dr. Enlander, and I have pleasure in this week's seminar to introduce Eisha Gupta from Mangalore, India, who's going to address us on the intricate comparison and contrasting cancer to ME CFS. It should be actually emphasized that ME CFS does not lead to cancer, and we're just using cancer as a condition which also has fatigue and has got certain similarities in immune disturbance, even though the immune system is not intricately related between cancer and ME/CFS. We are using it as a comparison to contrast the two conditions. I'll actually speak at the end of Aisha's talk, and we will actually now introduce Aisha.
Hello everybody, I'm Dr. Eisha Gupta and I'm going to be comparing and contrasting chronic fatigue syndrome and cancer. Copernicus stated in the early 1800s that the earth is round, and he drew a lot of flack for that until the same was proven by Columbus, who discovered the Great Americas. Much like ME CFS, which was believed by some to be an imaginary illness of the mind and not given the biological credit that it deserves. I'm going to compare and contrast non-Hodgkin's lymphoma with ME/CFS. The cause of chronic fatigue syndrome is not fully understood, and obviously neither is cancer. Immune system abnormalities, viruses and/or viral infections may have relationships with ME/CFS and certain cancers. The biological plausibility of ME/CFS is relatable with the picture drawn with that of non-Hodgkin's lymphoma. The similarities that may confuse the practicing physician are immune abnormalities, including dysfunction in the NF-κ beta, the excessive cytokine release, which is seen most often in ME/CFS, leads to pathology which can cause apoptosis or cell death, and oxidative stress which causes protein breakdown and fatigue. The total effect on the body is that vital proteins are broken down, and this leads to eventual whole body fatigue. The second similarity between non-Hodgkin's lymphoma and ME/CFS is NK cell dysfunction. Natural killer cells are specific T-cell lymphocytes which play a major role in host rejection of both tumors and immune response to virus and virally infected cells. NK cell activation leads to cytolytic activity causing cell death. NK cells are the big common ground between cancer and ME/CFS. The immune disruption leads to malfunction of natural killer cells in both the disease. At the same time, the more tangible cause of immune breakdown could be environmental and situational. For example, arranging a meal becomes a task when one is fatigued to the point of breakdown, which is common between ME/CFS and also non-Hodgkin's lymphoma or other cancers. In cancer, the poor nutrition of the patient due to decreased hunger and the tumor cells ravaging on the body's energy sources can also be the cause of immune breakdown. To keep the immune system healthy, one has to ensure good nutrition because energy and food are synonymous. Infectious onset is another point which is strong in commonality between ME/CFS and non-Hodgkin's lymphoma. Often we see patients walking into the clinic who suggest that they have had severe flu-like symptoms, or in other terms, a severe viral infection. The 6 viruses that have been time and again associated with chronic fatigue syndrome are parvovirus, cytomegalovirus, Epstein-Barr virus, Coxsackie, HHV6. There is evidence to link viruses like Epstein-Barr with Burkitt's lymphoma and suggestion of a relationship of hepatitis C with non-Hodgkin's lymphoma. There are multiple similarities between cancer and ME CFS. There, however, is no direct relationship proven as of now. The multiple things that we can link with ME CFS and cancer include a disturbed circadian rhythm. Both patients with ME CFS and those suffering from cancer suffer from non-restorative sleep. In simple terms, the patient may sleep for 8 to 10 hours a day but still feels exhausted on waking up. This can be attributed to disturbed sleep spindles, and changing sleep patterns has not been of any help till now. Another topic of common discussion could be chronic inflammation. Research has time and again proven that chronic inflammation causes a variety of cancers. For example, inflammatory bowel disease leads to colon cancer, and so does Crohn's and ulcerative colitis. Decreased functioning of the HPA axis in CFS patients can lead to increased stress response, leading to an exaggerated release of inflammatory cytokines, causing chronic inflammation. Again, we draw a parallel between ME CFS and cancer. Lymphadenopathy. 95% of the world's population has exposure to Epstein-Barr virus. Complaining of swollen glands or lymphadenopathy is common in ME CFS patients. Patients with cancers like Hodgkin's lymphoma, non-Hodgkin's lymphoma, and also the rarely seen Burkitt's lymphoma also suffer from lymphadenopathy, as it's most often is seen that the cancer grows in the lymph nodes. Anemia. The cancers most often associated with anemia are leukemias, colon cancers, and lymphomas. In colon cancers, there can be excessive bleeding, leading the patient to develop clinical anemia. And lymphomas destroy the ability of the marrow to mature the red blood cells. Malnutrition in ME CFS can lead to decreased iron reserves, decreased absorption capacity, and loss of appetite are some of the reasons why ME CFS patients face fatigue. Another important topic that I want to speak about is secondary depression. And again, I would stress on the fact that it is secondary depression, loss of functionality, and a compromised lifestyle with ME CFS patients leads to depression, the fear of the unknown, and the possibility that they may never again regain function or be who they were, and makes them lose hope and they develop secondary depression. Cancer also causes secondary depression due to the morbidity, mortality associated with the disease. The terminal nature of a variety of cancers leaves the patient distraught and hopeless. Interestingly, cancer patients have a better outlook towards depression and they fight it harder. This could be due to the fact that patients know that cancer itself is causing their fatigue, or that having a terminal illness makes a need to live their life to the fullest. While uncharted waters of ME CFS, unknown reasons as to the cause of their disease, can lead to severe depression. It can be daunting for the patient to overcome the fatigue and deal with the depression. I would also like to talk about a point where we associate a lot of social stigma with CFS, which makes the patients wish that they had a diagnosable disease with a possible cure, and is one of the causes for the ceaseless depression. The most important topic of discussion should be fatigue, because we are talking about chronic fatigue syndrome. Fatigue alone, without other symptoms, may be the first sign of concern for people suffering from leukemia and lymphomas. Tumors can also be the culprits of fatigue. Cancer cells aggressively combat with healthy cells for nourishment and most often deprive the body of essential nutrients, causing tiredness. Unexplained fatigue, which is debilitating and is the hallmark of ME CFS. The patient is constantly tired and unable to carry out daily activities, often the need to maintain a horizontal position. The gravity of the situation is such that we have patients who are labeled lazy. The PACE trial, for example, classifies CFS as a disease of the mind and one which should be treated with cognitive behavioral therapy and exercise, which does not help and in fact hinders the condition of the patient, making it worse and aggravating the fatigue. Finally, I would like to talk about the association between the Epstein-Barr virus and ME/CFS and lymphoma. The year of 2015 was the 50th anniversary of the discovery by Michael Anthony Epstein and John Barr of Epstein-Barr virus, particles in the cell lines cultured from tumor tissue from a Burkitt lymphoma. This work on the EBV virus led to at least 20,000 scientific papers on the characteristics, functions, infections, and oncogenic mechanisms of viral genes. Our current understanding of EBV DNA and herpes virus is not well understood. The cellular action of EBV virus is complex. 95% of the population is exposed to the EBV. Myung-Soo Kang, a molecular biologist and virologist at Sung-Kyung Kwan University School of Medicine, Seoul, Korea, identified a mechanism of EBV, low molecular particle 1 induced NF-kappa beta activation, and the roles of latent EBV genes and mitochondrial RNAs. EBV causes an acute, debilitating, fatiguing infection called acute mononucleosis. Classically, this usually persists for 6 to 8 weeks and the patient recovers. A small percentage of the patients, though, have massive persistent fatigue which lasts for years at a stretch, not necessarily related to the common EBV normal infection. A small number of patients can have a subset of Hodgkin's lymphoma or diffuse large B-cell lymphoma or endemic Burkitt lymphoma. Epstein-Barr virus positive B lymphoproliferative diseases can produce non-malignant reactive hyperplasia, causing enlarged lymph nodes, and some EBV positive DLBCL exhibit rare genetic alterations. However, EBV positive non-malignant LPDs and EBV positive DLBCL more frequently expressed NF-kappa beta P50 phosphorylated STAT3 and CD30 compared with EBV negative DLBCL. It is thought that development of EBV positive T and NK cell LPDs is closely associated with ethnicity or genetic predisposition. A unique feature of EBV is CpG island hypermethylation, including both promoter and non-promoter CpG islands of human genome. EBV infects only humans in nature and a limited number of animal species under experimental conditions. Humanized mice can serve as infection models for human-specific viruses that target cells of the immune system, such as EBV. An immunodeficient mouse strain after transplantation with cord blood hemoptytic stem cells is able to reconstitute most major components of hematolymphoid system, including T cells, B cells, natural killer cells, macrophages, and dendritic cells. The development of L-asparginase containing regimens in lymphoproliferative disease together with allogenic stem cell HSC transplantation may lead to improvement in treatment of EBV infection, which may in turn help our methods in ME CFS. I would like to say that the odds ratio between cancer and ME CFS is 1. So the question is yes or no. We still don't know. I would like to pass on to Dr. Enlander.
Thank you, Aisha. Aisha, you've done a great job. What we would like to actually show in this presentation is not necessarily the exact comparison of cancer to ME CFS, but to certain bodily reactions of the immune system and the body's reaction to a viral infection. We actually see that, as Aisha has said, that certain NK cells are reduced in ME CFS, and certain cytokines are abnormal. The methylation cycle in ME CFS is abnormal, and that is basically what is, we believe, causing the problem. As Isha has actually pointed out, some stem cell therapy has actually taken place in certain lymphoblastic conditions, and maybe actually we can use some of this knowledge in the treatment of ME CFS. Thank you very, very much again. Bye-bye.